Dear students, in this session we are going to see about series and parallel combination of resistors. So what will happen when the resistors are connected in series and parallel in a circuit? So this is a simple circuit which shows that the resistors R1, R2 and R3 are connected in series one after the another, that is a series in a circuit with the battery, key and ammeter which are also connected in series. So whenever you are going to solve this type of the problems in series and parallel, so not only in series resistors, in future in higher classes you are going to study about the capacitors in series parallel and cells in series parallel. For all those questions you should keep this hint in your mind. That means in series combinations the current value is remain constant for all the resistors. That is the current value not changed for resistors R1, R2 and R3, and potential difference only changed. That means in resistor R1, R2 and R3 the current value does not change. For all the three resistors the current value will be same, I only. But this battery voltage V will be split up into voltage V1, V2 and V3 according to the value of the resistance R1 and R2 respectively. So very simply I will say that so V is equal to IR. So whenever there is a change in resistance, correspondingly the voltage, the potential difference is changed, because in series combinations this current is constant. So by Ohm's law, so we are going to derive the derivation for this series combination. By Ohm's law, V is equal to IR. Here in this suffix I will put S. That means this resistance is total resistance of all the three resistors are added up. So how we are going to find this total resistance of this circuit? So that is V is equal to IR. So by using this formula, so only the current value remains same. For the resistor R1 the voltage is V1, for resistor R2 voltage is V2, and resistor R3 the voltage is V3. That means correspondingly the voltage values are changed with resistor values changed, because the current value remains same. So the total voltage is equal to V1 plus V2 plus V3. Substituting this V1, V2 and V3 in this equation, and the total voltage which is equal to I into RS, that is by Ohm's law V is equal to IRS. Here I substitute V is equal to IRS. So in this equation we are taking the current I commonly outside, then R1 plus R2 plus R3. I get cancelled, then finally we get the total resistance of this circuit in series combination is R1 plus R2 plus R3. That means if in any given circuit, if the resistors are not a three resistors, if it is a n number of resistors are connected in series, means merely simply add algebraic sum of all the resistors is equal to total resistance of this circuit. Now we are going to see about what is a parallel combination. In parallel combination, this is the circuit. So the resistors are connected in one after the other, that is one by one, R1, R2, R3. So the circuit is here, it is connected with the battery and the key, and the circuit is closed. So as in the series combination the current remains same and the potential difference is variable, it is just opposite. That means in parallel combinations the current is a variable and the potential difference is same. That means for the resistors R1, R2 and R3 the total voltage V is same for all the three resistors, but the current value only differs. In series combinations the current values remain same for all the three resistors, only the voltage value changes. Please students understand that in series voltage value only changes, in parallel the current value only changes. According to Ohm's law, V is equal to IR. So I is equal to V by R. So because I only changes, whenever the current, the total current comes here, so based on the resistance value of the R1, R2 and R3, the current will be split up, because by obeying the Ohm's law V is constant, So when the R1 is changed, the I is also changed. When the resistor is R2, I is also changed. So that is we are going to do by using this formula. I is equal to V by RP. The P represents the parallel combination total resistance. In this equation, S represents the series combination total resistance. Okay, by Ohm's law, V is equal to IR, that is for the resistor R1, the current only changes as I1 and potential difference remain constants. For similarly for the resistors R2, R3 and we get this equation. So what is the current in the resistor R1? I1, which is equal to V by R1, and I2 is equal to V by R2 and I3 is equal to V by R3. So what is this? This equation is very simple. From this these three equations we are arrive this I1, I2 and I3. So what is the total current? Merely there's a combination of addition of I1 plus I2 plus I3. Just to substitute the I1, I2, I3 in this equation, we get that V by R1, V by R2, V by R3. Taking the V commonly outside, we get the equation 1 by RP, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in parallel combinations, if the equation becomes a reciprocal manner, but in series combinations, the equations becomes in direct additions. In order to understand the series and parallel combination, let us take one small example, numerical examples. So the resistor R1 value is 1 ohm, R2 value is 2 ohm and R3 value is 3 ohm. So for series combination, what is the formula? Rs, which is equal to R1 plus R2 plus R3. Just you add 1 plus 2 plus 3, which is a 6 ohm. That is the total resistance of that circuit which has a resistance R1 and R2, R3 connected in series. For parallel, what is the formula? 1 by Rp, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So just you substitute 1 by 1 plus 1 by 2 plus 1 by 3. You take the reciprocal, you get the answer 11 by 6. So students, clearly most of the students in examinations, they are doing these calculations very clearly and immediately they will take that Rp, which is equal to 11 by 6. They forget the reciprocal because it is a 1 by Rp. So we have to take the reciprocal of this value is a correct value for the total resistance of this circuit. So Rp, which is equal to 6 by 11. The value of 6 by 11 is 0.54 ohm. So don't forget to take the reciprocal in the parallel circuit combinations. So by this problem, we come to the conclusion the total resistance is increases for the series combination and it will be very very low for the parallel combination. That is, the total resistance is increases and decreases correspondingly for series and parallel combinations. During the examinations, in questions, the students were confused with something, because in the questions they will ask that find the equivalent resistance, find the total resistance, find the effective resistance. So these three words, all the things are same, represent the same meaning. That means total resistance of the circuit. They may give the circuit diagram to find the equivalent resistance. These are all the problematic things we are going to see in the separate session at the end of this unit as a problem session. Now, what is the advantages of connecting a series and parallel combinations? In series combination, there is a disadvantages only we have, because if I connect the heater and the bulb in series, so heater has a higher resistance, bulb has a low resistance. So if these two are connected in series, then what will happen? The heater need more current to run, bulb need only less current. But in series, what will happen? The current will be remain same for all the components. So the circuit not works properly. That means if the more current will be flows, means the bulb will be damaged. If the sufficient bulb current only flows in the circuit, means the heater will not work properly. So the another disadvantage of the series combinations is if one of the component is damaged, then the entire circuit does not work. Sir, how sir? It is very simple. That is, this is a heater, this is a bulb, and this is some other electronic devices. If this R2 is damaged, this is damaged means the current will not flow from R1 to R3. That means the circuit will be breaks. The entire device, the entire home devices will not work properly. That is the main disadvantages of series combination of resistance. What about the advantages of the parallel combinations? The advantages means the current is divided accordingly based on the electrical devices. That means by using the formula V is equal to IR. Here the voltage remains constant. Whenever there is a change in resistance, the current value accordingly changes. In our domestic circuits, in our home appliances, all the circuits, all the fan, light and fridge, everything are connected only in parallel combinations. When the fridge is not working, the remaining TV, AC and all the things are works. That means if one of the component is failed, then the remaining component it will be works properly. That is a very important advantages of the parallel combinations. That is, it is very easy to locate the damaged devices and even works if one of the devices damaged. So in parallel combinations, the current is correspondingly given to the according to the electrical devices value. That means for heater, it will, if the heater and the bulb are connected in parallel, what will happen? The same 240 voltage will be given. That is a 240 voltage only supplied to our home. So if this 240 voltage is given to bulb also, 240 voltage is supplied to the electrical heater also. Based on this resistance of the heater and based on the resistance of the bulb, by using the formula V is equal to IR, based on the resistance value, the corresponding current value will be passed through the bulb and the heater. So both the bulb and heater will work properly in the parallel combinations very clear manner. So now we are going to conclude ourselves. So in this session we are seeing that what is a series and parallel combination of resistors, what are all the advantages and disadvantages of their parallel and series combinations.